In this video, we will be talking about the lesson of balancing chemical equations. So first, let's start with the definition of what a chemical equation is. A chemical equation shows a list of reactants at the left side and the product at the right side. So as you can see in this example, um, our the left side, the chasm between the left side and the right side is the arrow sign that goes to the right. This sign is our equal sign in this science lesson. If we acknowledge that the equal sign for mathematics is how we know it, for this science lesson, for balancing chemical equations, our equal sign would be the arrow to the right. Now, um, so with that said, this is going to be our left side, which will comprise of the reactants, and the right side will comprise of our product. And we have to bear in mind about the law of conservation of mass. It basically defines that total mass of the object transforming will not change. So the total mass of the reactants will still be equal to the mass of the product, as said here. The total mass of reactants will be equal to the total mass of the product. The mass will be the same. Therefore, the number of moles basically the number of moles basically refers to the mass um, involved in a reaction will remain the same all throughout the reactions. So whether the moles are here in the left side, it will still be equal. The quantity will still be the same in the right side. Basically, reactants are equal to the product. Apart from that, the chemical equation is not balanced. And with that said, the chemical equation cannot exist when the number of moles in a reactant is not equal to the number of moles in a product. So it basically says here, a chemical equation can only be used properly when the chemical equation is balanced. So let's write. Suppose we have this example, 3 mg plus 1 Fe sub 2 O sub 3, then we place our arrow to the right sign, then 2 Fe, then plus 3 magnesium, then O. So there. The coefficients are the number of moles, as you can see here. The number 3, number 1, number 2, number 3. For the subscripts, they mean those that are written in purple for a while. These numbers, sub 2, sub 3, they mean the quantity of that element. For example, here in Fe sub 2, they mean 2 irons because Fe is iron according to the periodic table. And O sub 3 means 3 oxygens. With that said, for the coefficients now, they are the number of moles. The number of moles are defined as the weighable amount useful for synthesis, for combination, or decomposition. If a reactant is weighable, the product is also weighable. Just as how the reactant should be equal to the number of moles in a product, the reactant and product should altogether be weighable. And speaking of weighable, they are also tangible. They are they can be touched by physical means. So, should the number of moles be unbalanced, as I said earlier, if the number of moles either in the reactant or the product be unbalanced, the chemical equation will not happen. There will be no such thing as a chemical equation with unbalanced reactants and their corresponding products. So now the question is, how do we balance chemical equations should these chemical equations be unbalanced at the first place? Well, we have to assume that the coefficients are unknown. So we've had the same example as earlier. Please don't see the coefficients as of now. For the sake of the discussion, we will be assuming that we don't know the coefficients. So here, this is a table that I created from the lecture. Um, Basically states how many, uh, actually, the amount of element, that basically means the subscript. So let's place that underlined in purple. As we've seen a while ago, subscripts mean the quantity of that element. So for magnesium, we can't see any number that is below. So obviously, it's already understood that it's Mg sub 1. So by the way, the elements here fall under the reactant side, and this is going to be the product side, which is this. So we now understand that Mg is sub 1, so just one element of Mg. For iron, for Fe, we have Fe sub 2, so we have two of them. For oxygen, we have sub 3, so we have 3 oxygens. At the other side, the product part of the chemical equation, we have 1 magnesium, 1 iron, 1 oxygen. Because there are no subscripts written, it is already understood that their default subscript will be 1. Just as how for mathematics, we understand that 2 is still equal to 2 is still equal to 2 raised to 1. Whatever the number is, for example, 1478 is equal to 1478 raised to 1. Doesn't change the quantity whatsoever. Alright, let's go back to our lesson. The number of elements on each side is not the same. It is understood. Well, for magnesium, they're equal, but it won't be equal because the other elements are not equal to each other. So we'll not consider that as equal as of now, because with how we are to balance chemical equations, it's going to affect magnesium in some way, because as you can see here, magnesium is aligned with oxygen, and whatever the coefficient here will affect whatever quantity will magnesium and oxygen have. So with that in mind, yes, we acknowledge that the equation is unbalanced, and now to balance it, a coefficient must be placed in front of the chemical formula. So yes, as I said a few seconds ago, we need to place a coefficient in which the numbers would be equal to each other. So it's basic math, if I suppose, because, for example, we have 2 here for iron and we have 1 for iron in the product side. To get I'm not really how to say this in English, but how do you get 2 provided that you get 1? So in that case, maybe 1 times 2 is 2. So that's going to be one of the processes that we'll be using to balance the chemical equation. So I'm giving you a hint right now, a foreshadowing. Alright, so the whole chemical formula is multiplied by that number of times. So yes, as I said earlier, there's some sort of, in mathematical terms, distributive property when we place a coefficient here. For example, let's place x. This variable will affect the quantity of magnesium and oxygen. For here, we place the number y, variable y. It will affect iron and oxygen. So that's what it means. Let's go with this example. So as you can see here, actually let's remove the process for now. Let's solve this one by one. Alright, let's see. For magnesium, yes, they're equal to each other. For iron, they're not equal to each other. Oxygen, they're not equal to each other. Please note that this part is the reactant side, and this will be the product side. So now we acknowledge that Fe here is 2 and Fe is here. Fe here is 1. So let's place times 2 to make this equal to each other. So these will be equal to each other. There. And provided that the product side will place to Fe. And the other side will just place it as is. To find our oxygen, to balance them, we should acknowledge that to get 3, we must multiply 1 with 3. So with that, our product, let's place 3 here. So again, we assume that this is distributive property. Our oxygen will have 3 oxygens, and for magnesium, this will also be multiplied to 3. With that, this time, magnesium is unbalanced, but at the expense, at the positively speaking, at the expense that we've made iron and oxygen balanced. So, for magnesium at the reactant side, let's just place 3 times 3, which is equal to 3. Now, give me a few seconds to recalibrate what we've just done. Well, for this part, let's just place a coefficient 1 because we have nothing to do with it anymore. These no longer require any change in their coefficients, so we just place 1 here. In this case, we have 3 magnesiums in the reactant side, and also on the product side we have 3 of them. So it makes the Mg equal. For iron, they're both 2, as you can see, so they're equal. For oxygen, we both have 3 on both sides, so these are equal. Therefore, I just rewrote the answer from earlier. So this time it's considered balanced. This chemical equation is balanced. I hope you're getting how we solve it. There's still some sort of mathematics behind this. So if you're wondering, by the way, you can see the answers right now. Well, please do not misinterpret this. I purposefully placed the answer key here in advance so that you may take note of it, because this is just an example. Please expect that there will be a video after this that will primarily focus on solving a few problems in regards to chemical equations. So, without further ado, let's proceed. This example basically requires you to memorize the ions. Not sure if ions and polyatomic ions are the same, but according to my science teacher, we do have to memorize ions so that we can discern which element is different from which element. If that seems to be a little confusing, well, imagine that you don't have this table yet. So I'm going to ask you now, what if, how do you list the tables? So you place here CA sub 3 and PO sub 4, then open close parenthesis, we have a sub 2 at the outside, the subscript. For Na and O sub 3, do you think they're the same? They're in one element piece? So that kind of confusion may be prevalent when you don't memorize the ions. Therefore, the memorization of ions is important. So please expect another video about that in the future. We'll be tackling basically all the ions, hopefully. If the video would be too long, we'll divide the lesson into chapters, into parts. So yes, back to the lesson. So we've just enlisted the subscript quantities of the elements in the reactant and product side alike. So I'm running out of pen, I'm sorry. For calcium, let's see what we could do. It is understood that every element here, the quantities of the subscripts are not equal to each other. So this chemical equation really is unbalanced, provided that we just leave it with the coefficients of 1. So it's really, really wrong. This chemical equation would never exist at all. So let's start with calcium. Let's multiply this with 3 at the product side. So find where calcium is. It's over here. So place a coefficient there, and there will be 3 calcium. For NO sub 3, it's equal to 2. Well, you have to multiply that to 3 because, again, there's a sense of distributive property here. So we get 3. By the way, the PO sub 4 is called phosphate, and NO sub 3 is nitrate. It's not all the time that we deal with periodic elements in the periodic table. It's not all the time. Sometimes we encounter ions. So yes, again, to be really, I'm trying to force you right now, so that you can ace the exam for this. You have to memorize the polyatomic ions. All right, let's go back to the lesson. Uh, so now for the reactant side, it's no longer equal. Even since a while ago, it's not equal. 1 is not equal to 3, so let's try placing this with 3. And we place 3 here. Distributive property. For sodium, we also multiply that to 3, by which these will be equal now, and as well as the nitrate and also 3. In that case, it is understood that calcium is already equal to each other on both sides, the product and the reactants. Let's just copy paste this. There you go. Oops, sorry. Wrong position. What am I doing? Alright, there you go. So what we have to equalize now to make balance is the phosphate. We put times 2 here. Where is phosphate? Over here. So in that case, distributive property, yes, phosphate will be equal to the phosphate on the reactant side, but for sodium, unfortunately, we'll have to multiply that to 6. And so, hang on, I'm sorry about this. I think there's a slight miscalculation in my solution. Let's remove all of these first. For sodium, provided that we place here 2, it will make balance the phosphate and calcium. Calcium for earlier. For sodium, Na sub 3, we place times 2, we get 6. So in order for Na from the reactant side to be equal with that of the product side, we also multiply it to 6. So here Na has to be equal with 6. So for NO sub 3 should also be equal to 6. And actually, a while ago, we did know that we'll be using distributive property to calcium and nitrate. So in that case, we'll just have to multiply this with 3, and we get 6. There you go. Now, we'll be translating this to a new illustration, so they're balanced. Alright, I suppose that's it for this video. Please expect again for the next video to be all be about the practice problems about balancing chemical equations. I hope you've understand how to solve chemical equations. Actually, not solve, balancing them. So yes. Thank you for watching this video.